force and acceleration. Let us take a glass marble and let it roll on a big smooth tabletop. What do we observe? We observe that after some time, the velocity of the marble decreases and it stops. On a carom board too, the carom coin pushed by a striker moves forward some distance and then comes to a stop. However, if we apply some talcum powder to the carom board, and then if we push the coin, then the coin keeps moving for a longer time and then comes to stop. What can we infer from these examples? The velocity of the coin decreases due to the force of friction and the coin stops. If the friction between the carom board and the coin is reduced, we use talcum powder to do this, the coin keeps moving for a longer time. It implies that if no force of friction is acting on a moving body, it will keep on moving with a constant velocity. The scientist Sir Isaac Newton was the first to study force and the resulting acceleration. He proposed the laws of motion. Let us learn about Newton's first law of motion. Newton's first law of motion. According to Newton's first law of motion, if no force is acting on a body, its velocity does not change. That is, the body does not accelerate. In other words, if a body is stationary, it will remain stationary. If it is in motion, it will continue moving with the same velocity and in the same direction. After understanding about force and acceleration, let us now define unit of force. If 1 kilogram standard weight is placed on a surface with no friction and pulled with an acceleration of 1 meter per second square, then the force applied is called 1 N or 1 Newton. Newton is the SI unit of force. 1 Newton is equal to 1 kilogram meter per second square. We have learnt about force and acceleration in detail. We know that acceleration is a vector quantity. Is force also a vector quantity? According to Newton's first law of motion, when a force is applied on an object, acceleration takes place. The effect of force depends on both magnitude and direction of the force. The force can increase or decrease the velocity. Sometimes, the magnitude of velocity may remain constant, but the direction of the velocity can change. This shows that force is also a vector quantity. Come, let us do one activity to understand the relation between force, mass, and acceleration. Activity. Let us spread some talcum powder evenly on the surface of a small wooden table and place a weight of 1 kilogram on it. Let us now pull the weight with an acceleration of 1 meter per second square. Since 1 kilogram weight is pulled with 1 meter per second square, the force applied is 1 Newton. Let us now pull the weight with 2 meter per second square. This means that the force applied is 2 Newton. From this, you must have surely understood that force is measured by the acceleration that it produces. Force is equal to mass into acceleration. We have learnt about the relationship between the displacement of a body resulting from the force applied to it and the work done. We have also learnt about the work-energy relationship and that the ability to do work is called energy. Come, let us now learn about the relationship between force, displacement and work.